7.5, multiplying a polynomial by a monomial. These notes are going to be pretty bare because the problems are all just basically distributing and doing stuff like that. So here I have a problem where it's negative 2x squared times the entire quantity of 3x squared minus 7x plus 10. By this point, you might want to be avoiding having to show that these terms are getting distributed all the way across, but it's still going to be a nice strategy. So I'm going to encourage that you still do it. And again, these notes are called multiplying a polynomial by a monomial. So in red, you don't have to write the things in red, but we have a polynomial, meaning it is made up of multiple terms, and we know that because they are separated by minus and plus signs. So we're multiplying a polynomial by a monomial, which is just one term. And most of the time when we're given these, the part with the more terms is usually going to be arranged in order of decreasing degree. So that would be x squared, x to the first, and then x to the 0 power, So I will write this out in red, meaning this is an optional step. If you wanted to see that you'd really have negative 2x squared times 3x squared. And then I see these minus signs that agree. So I know a minus times a minus would give me a positive. And then I'm going to have 2x squared times 7x. And then I move on to the final of these terms where they match up. And I'm going to have a minus hitting a positive, so minus 2x squared times 10. But I'm showing that in red because I really do consider that to be optional. A lot of people are going to feel mostly comfortable going straight from doing 2 times 3, looking at the terms first, which would become 6, x to the 4th power. And now they're assuming that that's feeling comfortable from the previous sections, because when we multiplied anything with a power times a different one, we know we can just sum those powers. So in this example that I'm looking at, this 2 and that 2 give us 2 plus 2 to get this 4. And like I said earlier, a negative times a negative gives me that positive. So I'm going to have plus 14x cubed. And then lastly, minus 2 times 10 is 20, x squared. And this is where I do like to kind of check the problem, be like, well, this was 2, 1, x to the 0. So it's counting down. This is also counting down 4, 3, 2. We're good there. And I can really look at this and be like, well, the second times that second gives me a 4th. Just ways to go ahead and check these problems out, maybe without doing the whole thing. But if this were a quiz or a test, you could redo the entire problem. Here's a new problem that you can try on your own before I start talking about it, but give yourself time to rewrite it and pause the video to get caught up. 5a squared times the quantity negative 4a squared plus 2a minus 7. And these ones also are in decreasing order. And we have a monomial out front, meaning its mono is 1, it's only one term. And then we have a polynomial, and I could be more specific. It's not just a polynomial, it is a trinomial because there are 3 terms that make it up. Now I look at this 5 out front, and I know that this 5a squared is going to distribute to every single term. So looking only at the coefficients of my terms here, I see 5 and 4, and 5 times 4 gives me 20. And the positive 5 times the negative 4, I'm going to have to make that negative overall. A squared times a squared will be a to the 4th. And then I have, to move on, I have a positive 5 times a positive 2. So that would be plus 10. I have an a squared and an a to the 1st power. So I'm going to have a cubed. This is optional. You don't really have to add that there unless it helps you. And then I have 5 times a negative 7, so I'm going to write minus 35. And a squared times an absence of an a there would just be a squared. I'm boxing this. I feel pretty good about it. You know, maybe you think that makes it look a little bit more ugly because it's a single term. And as I'm doing this, I'm looking through this problem and I'm making sure, are these all simplified? Can I combine anything? And you really can't in this one, so you're good to go. But like I said last time, we like to check the degree, 2, 1, 0. And then this is the squared term, so the squared would give me a 4, 3, 2, and here's my 4, 3, 2. And also just being thorough, I mean, you could recheck the entire problem in your head and make sure you did it correctly. So this is a completely simplified problem what we have here. And you can also say, well, did we find the answer to it? Yeah, we did. This is a slightly different problem, not much so, but really we're just simplifying some things. And so here they're like, well, maybe the students are feeling more comfortable, and we can make them distribute a couple terms. Maybe we can make them do the whole monomial times a trinomial deal. And then once they do all that, can you get it down to where it's, a lot less junk? So yeah, this is a simplifying problem. And if I want, I can make this, more clear by being like, well, this is 4 times 3d squared plus 5d. So maybe I make the color stand out. Minus d times d squared minus 7d plus 12. Just giving a little bit of color standing out so that helps me see that this 4 is getting distributed to the yellow terms. So I got 4 times 3d squared, so 4 times 3 gives me 12d squared. And here, because I'm just like multiplying by plain old numbers, this is a little bit more straightforward. So 4 times 5 is going to be 20d. And then I got this d is now going to distribute across to the d squared minus 7d and so on. And now I'll write minus d times d squared would stay negative. And I'm going to write minus d cubed. Then I have a negative times a negative gives me a positive 7d squared. And then lastly, I have minus d times 12 minus 12d. Notice that I'm not really talking heavy about the integers part and all that kind of business. But they really should be reversed, right? So if this was positive, down here it should be the opposite sign. If this is minus, down here it should be the opposite sign. If this is positive, down here it should be the opposite sign. So if I had a bunch of these, I could just kind of make sure I flipped them all. Okay, we got 12d squared plus 20d minus d cubed plus 7d squared minus 12d. None of these terms have disappeared. I'm not going to bother rewriting these and pairing them all up, but I'm going to scan through and I'm going to look for the numbers with the highest term. So going from the left to right, d squared, d cubed, d squared, d. So the highest term I have here is negative d cubed. So I'm going to write that first. So here is negative d to the power of 3. I scan through again, and I'm looking for d squareds, and I see 2 of them. And I have 12d squared, and then I have a positive 7d squared, so I'm going to write plus 19d squared. Keep on looking. I'm now moving down from the third to the second to the first degree, so I'm looking just for plain old d, and I have 20d minus 12d. I'm going to get plus 8d. I'm looking through my problem, making sure nothing can really be simplified beyond that. I had 1, 2, 3, 4, 5 terms in the first one, which went down to 3 in this term. And that was because 2 of them became 1, and another 2 of them became 1. Now that's probably seeming a bit obsessive, but I think by this point I've shown you 3 different ways you can try and check these problems. So as you're like a math student trying to work through tests and you want to be as accurate as possible and get as many points for quizzes and tests, that's different ways you can kind of sanity check your problems to make sure you're doing these correctly. Let's do another example to have in our notes, but make this an on your own problem. So go ahead and do this OYO on your own. And I'm going to pause the video in about 5 seconds and just have the solution. So start counting down from 5 and make sure you hit the pause before now. Now, even though you've probably done the problem, don't fast forward through this and don't speed it up and don't skip it. But 3 times 5x squared gave me 15x plus 6x minus 12. And the whole hope is like maybe I point some things out. But I got the left part in green, the right part in yellow. And looks like everything should check out here. It's pretty straightforward. You'll notice here, did you catch it? Got a minus and a minus. That should be positive. So, looking through my work, I was scanning here and checking to make sure my signs all went the opposite direction. Okay, that's this problem. Make sure that you scan through and verify that your terms are in decreasing order, 3, 2, 1, and then this would be x to the 0. And now let's see how we do on some slightly more challenging problems. Pause to read this, and then I'll read it aloud anyway. Assuming you've read it, I'll read it quickly. Real word problems. Phone service. Greg pays a fee of $20 a month for local calls. Long distance rates are 6 cents per minute for in-state calls and 5 cents per minute for out-of-state calls. Suppose he makes 300 minutes of long distance calls in January, and M of those minutes are for in-state calls. Find an expression for his phone bill in January. Okay. The most important thing that I try and push in doing word problems is stripping out the junk. So if I can take all these words and make it look a little bit more like a list of numbers that I can maybe then categorize or do something with, I think the better off I'll be. Okay, so the first thing I see is that he pays a fee of $20 a month. Okay, so the first thing I'm thinking about is, stripping the information. I got $20 a month. That's basically like a standard fee. There's no getting out of that. If it were January, February, March, he'd pay $20 a month. Has nothing to do with the number of calls he makes. Long distance rates are 6 cents a minute. Okay, well those are for in-state calls. So I'm going to write just 0.06 because a lot of these problems, it's going to end up having to have units that agree. So if I got a dollar sign there, I probably have to get my cents in dollars. If you ended up using 6 and 5, you'd get like crazy large numbers, and I think it wouldn't agree. Okay, the next thing I see is 5 cents a minute. So you go ahead and convert that to 0.05, and got my dollar sign there. Suppose he makes 300 minutes of long-distance phone calls in January, and M of those are for in-state calls. So this is really the total. So I'm not going to go crazy breakdown, but he's got 2 types of calls he makes, right? And the weird thing is, you're probably thinking there's long distance and non-long distance, but these are both, according to this, long distance calls. But there's, one type where he calls people in other states, but then I guess he calls people in state, which is kind of a little bit maybe further from his local town or whatever, I don't know. And this problem's also a little bit outdated because it's about phones, and we can thank the textbook for being so modern and current. So with these out-of-state calls, let's see, well, the M minutes is really the in-state, so I'm going to put M over here. But the out, I could be well, maybe that's O for out-of-state. That's kind of ugly though, right? But we just know that this is some other sort of mystery. All right, so here is the deal. We have M in-state minutes, X out-of-state minutes, but those both have to give us 300. Now here's where it's going to get a little bit more challenging. We know that he made M calls for in-state. We could figure out how many out-of-state calls he did if we were well, what if M were 10? Well, there was 300 total, right? And if he made 10 in-state calls, the other would have to be 290. So what if instead he made 100 in-state minutes worth of calls? That would be 200. But what I'm showing you is that really we take the total calls and we will subtract out the mystery number of calls. And this is what we'll use to get our out-of-state calls. Now I guarantee that unless you've done a handful of these problems, that is not feeling super comfortable yet. So by the end of the problem, see if it makes sense, and hopefully by practicing more of these, they'll feel a little bit more comfortable. You'll see a lot of problems like this with, there's X number of people in the room made up of adults and children, and then you got to figure out. The other bit of information we can move on to is, well, it's $20 per month. He's going to be paying that no matter what. So let's look and see if we can use what we know to figure this out. So no matter what, he's paying $20. I write that first, even though in a polynomial I would really try to avoid having that first. I'm writing it first because it's the easiest one for me to think about. The next easiest thing for me to think about is the fact that he makes M in-state calls. But we need to remember that the cost of an in-state call is 6 cents per minute. So I'm going to do M times 0.06. The next thing he does is he makes 300 minus m calls at a rate of 0.05. If you were to do a problem like this on your own and rearrange it in a different order, that's totally fine. Now I'm going to go through and I'm going to see if I can simplify. Well, because of the way I've written this, I'm going to have to distribute backwards. So I'm going to write out 20 plus, well, I like to see the number in front, 0 and 600ths times m, so 0.06 times m, plus 300 times 0.05. Now, if you're so wrapped up in this problem right now, and it's so much focus for you to figure the problem out, you probably don't want to go ahead and start all of a sudden confusing yourself by trying to figure out the decimals. But 3 times 5 would be 15, and you could relocate the decimal. But here's a good point of where it's nice to pull out a calculator and just figure out what to do, as opposed to confuse yourself by worrying about decimals. All right, so looking at this, I'm scanning through. I'm looking for anything with an m. So I see 0.06m, 0.05m, and I'm going to subtract that, and I'm going to get 0.01m plus, I see numbers, 20, 15, gives me 35 total. So 0.01m plus 35. And this would be the expression that would give you his total cost if we were feeling like calling it capital T. All right, so that's A. Now, 0.01m plus 35. It only takes me another moment to end up rewriting that equation. I'm calling it an equation because I use T. But if I just wanted to call it an expression, which is really what they're asking for, I'd put 0.01m plus 35. And I'd leave this part off because that would make it an expression. So, 0.01m plus 35. Evaluate the expression to find the cost if Greg had 37 minutes of in-state calls. So this is the easiest part because you're like, okay, I've done all the work now, and now I can just multiply by 37, add on that 35 at the end, and hopefully get 35.37. Probably should make that 2 steps, excuse me. And since it is a word problem, get a $sign there, and this would represent January cost for Greg. Let's revisit what we did there. It's a brutal problem, but it's kind of like awesome once you get in the habit of doing these. So let me just remind you of some of the strategies before you try to go on and do some of your own. So we got the real world problem, right? I went through and I scanned for all the junk, trying to filter it, maybe even mapping it out, stripping out what I could and turning it into variables and numbers. And then that really is what ended up getting to the expression that we had to find, to represent this real world problem. And then once you get here, this is easy, but obviously if you don't get the problem set up correctly, it really makes it difficult or near impossible to do this part. And having seen one, it's not like you're going to feel super comfortable. So we'll sit together, check out a couple together, go through some as a class, and this is how you would multiply polynomials by a monomial, and this is a good set of problems for this section.